A kilonova explosion, also known as a macronova or a R process supernova. Okay, these two names are also used, either macronova or R process supernova. A few days back, I have already posted a video on supernova explosion, and this is a video on kilonova explosion. Okay, both are almost similar. You know that in case of supernova explosions, heavy elements are produced, and in which cases supernova explosion occurs? We know that for the massive stars, I am not talking about sun, it is bigger than sun. Okay, so for massive, at the end of the life cycle of massive stars, supernova explosions occur, and during that process heavy elements are produced. Here also, in case of kilonova explosions, similar things happen. That means it is also a type of cataclysmic astronomical event. Okay, but here massive stars are not there. Here we know that at the end of supernova explosion, neutron stars are formed, and here in case of kilonova explosion, either two neutron stars take part in the merging process, and during the merging process heavy elements are produced, or in this event there is a presence of one neutron star and another one is a black hole. Means either there should be two neutron stars or one neutron star and one black hole. Due to the gravitational effects, they come close to each other and merge. Okay, so what is neutron star? I have already told you, at the end of the supernova explosion, the highly, extremely dense remnants of a supernova explosion is called a neutron star. Why neutron star? Because most of the particles present in the core region of a supernova explosion is primarily, okay, those are neutrons. That's why the name is given neutron star. So if in a binary system there are two neutron stars, okay, if in a binary system two neutron stars are there, so those two neutron stars may take part in the collision and the merging process due to gravitational pull or gravitational attraction, or a neutron star and a black hole may take part in this collision process. Okay, so collision and merging process all are happening due to the presence of gravitational pull. Extremely high gravitational pull is there. So now you know what is neutron star. Next is merging process, and during the merging process heavy elements are produced. What happens actually during the merging process? There is a burst of tremendous amounts of energy into the space. Okay, as well as with energy there is ejection of material to the space with extremely high velocities. Yes, materials are ejected during the merging process at extremely high velocities into the space. And during the merging process, since tremendous, excessively high level of pressure and temperatures exist there during the merging process, and this tremendous pressure and temperature causes nucleosynthesis. Mainly rapid neutron capturing process happens, which is also known as R process. And due to this R process, heavy elements are produced, and those are ejected into the space. And those ejected heavy elements eventually may form different planets, different stars, different objects in the universe or in the space, better to say in the space. Okay, and we know that life forms due to these different types of elements. Okay, any living organism is composed of so many types of elements, and these elements are produced during such merging process, whether it is a supernova explosion or kilonova explosion. But during the merging process or when there is nuclear synthesis process occurring, in that case these are produced. Again, with materials, electromagnetic radiation is also there. Since heavy elements are produced, so during the radioactive decay of those newly synthesized heavy elements, electromagnetic radiation is produced, and this varies from gamma rays to radio waves. Means across the entire spectrum you will get this electromagnetic radiation. Okay. Anyway, so this is all about kilonova explosion. And if you consider the luminosity or the brightness, means if you compare brightness of this phenomenon, means kilonova explosion, with supernova explosion, then the brightness of kilonova explosion is less as compared to supernova explosion. Means it is less brighter. Kilonova explosion is less brighter as compared to supernova explosion. You know that in case of supernova explosion, which is equivalent to illumination of billions of stars simultaneously, of course for a brief period of time. Okay. Anyway, so this was all about kilonova explosion, where the main theme was production of heavy elements like gold, platinum, uranium, okay, plutonium, bismuth. So many heavy elements are there. Means I am talking about elements beyond iron on the periodic table. In chemistry, you might have studied periodic table. Okay. Anyway, so this is the end of this video. Thank you. Thank you for watching this video.